Let us begin our journey into trigonometry. So our trigonometric ratios, that is sine, cosine, tangent, the sine of theta, the sine of some angle, this is the Greek letter theta, is defined as being the ratio of the side opposite it divided by its hypotenuse. And the cosine of theta is defined to be the adjacent divided by the hypotenuse. And what's nice is if we have two triangles that have the same angle, let's say this is a 30-degree angle, and I draw this triangle that also has a 30-degree angle, and pretend these are good triangles, right triangles, the ratio of the opposite to hypotenuse will always be the same. That's what this sine of the angle is telling us. And there's one more commonly used trig function, and that's tangent. Tangent is opposite over adjacent, or also sine of theta divided by cosine of theta. There's an acronym that we use to help us remember, SOHCAHTOA, SOHCAHTOA. Sine is opposite divided by hypotenuse. Cosine, adjacent divided by hypotenuse. And tangent is opposite divided by adjacent. Couple of notes here. Sine, cosine, and tangent are operations. It's like a square root symbol or a multiplication dot. If you just write sin equals 2/3, that's completely and utterly meaningless because we have to take the sign of something to get 2/3. And food for thought, I can remember when I was young and in high school and in my trigonometry class, I vividly remember writing this SOHCAHTOA across the top of countless different trig problems or countless trig assignments whenever I was needing to use it. So here we have a triangle. We want sine theta, cosine phi, or some people say phi, Greek letter, and tangent theta. So let's start with the thetas. And let's label the triangle with what the sides are compared to theta. C would be the hypotenuse, regardless of what angle we're talking about. Compared to theta, A is the adjacent. And going across from theta, B is the opposite. So sine of theta, think about SOHCAHTOA, sine theta is opposite over hypotenuse, so in this triangle it's B divided by C. Tangent theta, we'll come to B in just a second. Tangent of theta, tangent was opposite over opposite over adjacent, TOA, opposite is B, adjacent is A. So tangent of theta is B divided by A. Now, if we shift gears to phi over here, we have to relabel our triangle. We have to rethink about what the different sides are. Compared to phi, A is the opposite side, and B is the adjacent. The hypotenuse doesn't change. It's always opposite the 90-degree. Cosine of phi equals adjacent, B, divided by hypotenuse, C. And notice that sine theta and cosine of phi are equal. So now we have some calculation problems. We have numbers in these triangles. We want to find the unknown lengths. We start by setting up a trig ratio. So label them compared to the angle we know. X is the opposite side. 9.6, the side that we know, is the hypotenuse. What trig ratio uses opposite and hypotenuse? Sine does. So sine 61 equals opposite x divided by hypotenuse 9.6. This is an equation that we can solve. Multiply by 9.6. X is equal to 9.6 sine 61 exactly, but approximately. Let's jump to our calculator. 9.6 sine is under this trig button, and it was 61 degrees. And I'm going to put a degree in here just to make sure that I get the unit right. See the calculator video for more information about this. But 9.6 sine 61 degrees, push enter. Our side is approximately 8.40, rounding correctly or appropriately. 9.40, and we've got some units, centimeters. B, angle is 41 degrees. This 7.8 is the opposite side. X is the adjacent side. So opposite adjacent, we're talking tangent, ladies and gentlemen. Tangent 41 equals opposite over adjacent, TOA, T-O-A. It's the end of SOHCAHTOA. 7.8 divided by x. Now how do we get x here? X is down in the bottom of this fraction. Dividing by 7.8 isn't going to get that alone. First thing we do is multiply both sides by x. Now we divide by the tangent of 41 degrees. So x is exactly 7.8 divided by the tangent of 41, or approximately, back to the calculator we go, 7.8 divided by the tangent of 41 degrees. So this side of the triangle is approximately 8.97. 8.97 meters. And there we go. So when we write these down, I always like to write the exact value first, involving the trig function, and then approximate it. And unless I'm told otherwise, I like to round to hundredths. I think it's a good place to round to. It shows that it isn't an exact answer, but it gives us quite a bit of precision with what we're doing.